trigonometry, and probably some of you have never used trig. So what you need to do right now, if you don't have your graphing calculator with you, you need to pause this video, go find it, because I have to show you some things right off the bat with your calculator. All right, so let me get my calculator here and show you. So first thing we want to do, our calculator has a lot of different modes we can set it into, and we want to make sure that our calculator knows we're going to measure all of our angles in degrees. So what you're going to do, you see this mode button right beside the blue second button. You're going to press mode, and then you are going to scroll down to where you see it says radian. Right now my calculator's flashing on radians. I got to change that to degrees. So I'm going to use my cursor, come over to degree, and then I'm going to hit enter. And that is going to have my calculator all set for me. Now let me tell you, every time you have to clear your calculator, which you will have to do before every quiz or test, your calculator's default mode is radian, so you're going to have to go back in and reset it for degrees. Nobody's going to remind you to do that when you go to take the SOL, so you have to remember to do that. Go back and set it to degrees. All right, and when you want to get out of this mode, you just press your second button, and you see right above mode it says quit. So we want to quit, so we're going to do second mode, and that's just going to take us right out of there. Okay, we don't need that right now. We're going to go back and fill in some of our notes, and then we'll come back and use our calculator when we need it. Okay, so what does it even mean? What does trig even mean? Well, for our purposes, what we're going to do is we're just using the ratio of two side lengths of a triangle to determine what the angle measures are of that triangle. And whenever we have a right triangle and we want to find all the parts of it, all three of the side lengths and all three of the angle measures, well, of course, we know one of the angle measures 90 degrees. But when we want to find out everything about this right triangle, we refer to that as solving a right triangle. On the lengths of all three sides is known as solving. I should write solving there. Solving a right triangle means you find the two other angle measures and all three side lengths. All right, a ratio of the lengths of two sides of a right triangle is called a trigonometric, not trigonometric, but you can just say trig for short. We just like to say trig, keep things short. All right, so now we're going to just use three trig relationships. When you get to pre-calc, you'll do the inverse of these, but for now we're just going to use the first one. Is if we look at the side opposite an angle A and put that over the hypotenuse, this is known as the sine of angle A. Sine, S-I-N-E, and for some reason we abbreviate this as sin A, but please don't say sin. There's no sin here. We're not sinning. We just abbreviate the sine of angle A as sine A. All right, so let me see. I think we have a drawing down here that'll make all this clear. So we're just going to fill in these notes first. All right, and the ratio that relates the length of the side adjacent to A to the hypotenuse is the cosine of angle A, and we abbreviate that COSA, but we call it cosine. So sine A and cosine A. And then finally, when we're going to relate the opposite side, the side opposite angle A to the side adjacent angle A, that's the tangent of angle A. And of course, we abbreviate that T-A-N-A, tangent A. All right, so here's your diagram. So let's look. Here's our angle A. Here's our angle A that we were talking about just now. So if I'm looking at the side opposite, which is this one over here, divided by the hypotenuse, which is always the hypotenuse. So you see right here, the sine of A is the side opposite divided by the hypotenuse, which is A over C in our little drawing. That's the definition of the sine of angle A. It's the side opposite A divided by the hypotenuse. Cosine A is the side adjacent. So here's the side adjacent, which is B, divided by the hypotenuse. And the tangent is the side opposite A, which is A, divided by the side adjacent, which is B. So those are the three trig ratios you're going to have to use over and over. So you got to memorize those. All right, here's a little thing. You've probably heard of this. Maybe you have, maybe you haven't. But Sohcahtoa. There's actually a little story about Chief Sohcahtoa. I don't know the story, but I do know that Sohcahtoa helps a lot of people remember their trig ratios. Okay, so the S in Sohcahtoa is for sine, and then the O is for opposite. The H is for hypotenuse. All right, so sine is opposite over hypotenuse. C is for cosine, and of course A is for adjacent, H is for hypotenuse. T, you guessed it, is for tangent. O is for opposite, A is for adjacent. So if you can remember our buddy Sohcahtoa, that will help you to remember your trig ratios. All right, let's see how we're going to use this. Find the sine, cosine, and the tangent of angle P. Here's angle P. I'm going to put a mark on it so I know which one I'm looking for. Let's start with the sine, and I'm going to use our abbreviations. So the sine of P, what is it? It's side opposite over hypotenuse. What is the side opposite P? It's 15. What is the length of the hypotenuse? 17. So there we go. Can't simplify that. Of course, if I could, I would have to do that. All right, let's do the cosine. Cosine of P, what's the side adjacent P? It's 8. I mean, the hypotenuse is adjacent to P too, but the hypotenuse is always the hypotenuse. We don't use it as the adjacent side. So side adjacent over hypotenuse is 8/17, and then the tangent of P is going to be side opposite over side adjacent, so that's going to be 15/8. And that's all there is to finding your trig ratios. How about this? Let's find the sine, cosine, and tangent of 60 degrees. Again, when you get to pre-calculus, you will learn what's called the unit circle, and so you will actually memorize the trig functions for 60 degrees, 30 degrees, and many other angles. This is just one that we're going to do here. So we want the sine of 60. So the sine of 60 degrees is the side opposite, which is the square root of 3, divided by the hypotenuse, which is 2. Cosine 60 is side adjacent, which is 1, divided by the hypotenuse, which is 2. And the tangent of 60 is side opposite, which is the square root of 3, over the side adjacent, which is 1. So tangent of 60 is just the square root of 3. Okay, you just got to remember your ratios. Use the triangle to find the trig ratios for x and y. All right, let's start with x. Let's start with x here. Let's do sine x, then we'll do cosine x, then we'll do tangent x, and then we'll do the y's over here. Sine y, cosine y, and tangent y. So sine x, side opposite over hypotenuse. So that's 16 over 20. Got to simplify that. 4 goes into there, 4 goes into that 5. All right, how about cosine x? Side adjacent, which is 12 over 20. So that's going to be, let's see, 4 3/5. And tangent x, side opposite over side adjacent, is 16 over 12. So 4 goes into that 4, 3. So there are my trig ratios for angle x. And for angle y, the sine of y is side opposite. The side opposite of y is 12. The hypotenuse, 20 in both cases. So that's going to be 3/5. Cosine y is going to be side adjacent, which is 16 over the hypotenuse. So that'll be 4/5. The tangent of y is going to be side opposite over side adjacent, which is going to be 3/4. Something interesting there about those relationships. Think about it. See what you think. Okay, now, what if we wanted to find out what the measures of these angles above are? What if we wanted to know what the measure of angle x is and what the measure of angle y is? We can do that, but in order to do that, we have to use what's known as the inverse trig functions. I think earlier I said inverse, that you would learn the inverses in pre-calc, but I take that back. That's not really what I meant. We're going to do inverses of sine, cosine, and tangent today, so we can use these ratios to find out what those angle measures are. So whenever you see this sine to the -1, cosine to the -1, the little -1 exponent with your trig function, that means I'm trying to find the measure of an angle. All right, so you can use, what do we call this here? You can use an inverse. You can use an inverse to find the measure of the angle. All right, so let's see how that's going to play out down here. Solve the right triangle. Remember what I told you that means? Find all the leg lengths and the missing angles. All right, so here we go. Now, we could use the Pythagorean theorem to find the hypotenuse, but we're going to use trig to do that. So let's just start off with angle A. Let's start off with angle A, and let's see, we can do tangent. Tangent of A is side opposite over side adjacent. So the tangent of A is 2. All right, here's how we use our inverse. We say the inverse tangent of this number here, 2, equals the measure of angle A. So let's go to our calculator. And you see where your tangent button is. 4 rows down, 4 across, you see tangent. Well, you see right on top of tangent is the little blue inverse tangent. So we're going to use our second, let me put my marker down. We're going to go second tangent. So you see we got inverse tangent there, and we want the inverse tangent of 2. And then we're going to hit enter. That's going to tell us what the measure of that angle is, and let's see, we're going to round it, I guess, to the hundredths place. So we'll round that to 63.43. So let's just say A is approximately 63.43 degrees. All right, so now we could find the measure of angle B by just subtracting, because we know the sum of the measures of the interior angles. But let's go ahead and do it with trig. Let's go ahead and do it with trig. Let's do the tangent. Hold on. Let's look at angle B here now. Angle B. I'll do this in red. So I know that the tangent of angle B is the side opposite over the side adjacent, right? So the tangent of B is 4/8 or 1/2. Okay, so if I want to find the measure of the angle, I have to use the inverse tangent. So the inverse tangent of 1/2 equals that angle B, and then we're going to get an approximation again. So let's go back to our calculator, and it's 1/2. So we're going to do second tangent, and we have a half there. So I'm going to show you guys a neat trick to do fractions with your calculator. So what you want to do now is hit your green alpha button, alpha, and then you want to hit your y equals button, which is right up at the top, y equals, and then you're going to hit enter. So alpha, y equals, enter. Pause and write that down if you need to. And that's going to allow me to put a fraction in there. So now I'm just going to put 1 divided by 2. Could you just put 1 divided by 2 without doing it as a fraction? Yes, you could, but I was just trying to show you a nice trick. All right, so inverse tangent of a half is 26 point, we're going to round that to 5/7, so 26.57 degrees. So there we have all of our angle measures, and we need side C. We need side C here. So what could we do? What could we do? Well, let's just use our approximation that we got for angle A. So let's see, we know that, let's take sine of angle A. What is the sine of angle A, guys? Well, it's side opposite, which is 8, over the hypotenuse, which is C, right? Well, I have A, right? So I can plug that in, even though it's an approximation. 63.43. I'm plugging in an approximation, so it's not going to be as good of an answer as the Pythagorean theorem. The sine of 63.43 equals 8 over C. All right, we got to solve for C. So I know that C times sine 63.43 equals 8, right? I just multiplied, actually I cross multiplied, that's what I did. And now to solve for C, I got to divide both sides by the sine of 63.43. So let's do that with our calculator. Go back. 8. So I'm going to do 8 divided by, and I'm going to put in sine of 63.43, and that's going to give me an approximation of 8.94. So let's go over here. Say C is 8.94 approximately. Now, let's do that with the Pythagorean theorem and see how close we got. All right, if we use the Pythagorean theorem, I know that C squared equals 4 squared plus 8 squared, right? So C equals the square root of 16 plus 64, which is the square root of 80, which is 16 times 5, right? So 4 times the square root of 5. Let's go check with our calculator and see how close we got. Let's see what 4 times the square root of 5 actually equals. 4. Your square root button is right above x squared. Second x squared, 4 times the square root of 5. Enter. And I got very close, right? A little bit of error because I rounded that angle measure, but very close, about 8.944. All right, so there we go. What I'm going to do now is stop this video. The rest of it is really just some practice problems. Actually, just 1, 2, or 3. So I'm going to pause here. I'm going to put the solutions for the rest of these problems up, and you should work them and then check your answers.